Howdy friends, welcome to All About Relay channel. In this video, we will be seeing RTMS software home screen features. One of the powerful page in the RTMS software is home screen. So this screen can help you to test any relays in the market, starting from electromechanical relays, microprocessor relays, any static relays, uh, any type of like overcurrent relays, under voltage relays, or over voltage relays, differential relays, distance relays, even laws of excitation with the correct settings, you can able to test it. So this is a very powerful page, and it's a very simplistic and very intuitive test screen. As we see the previous videos, like a lot of icons in the top of the screen, which we already go through. I don't want to go through these icons, but rather I will discuss about the functionalities of each buttons. So the home screen have like connection status. If you click the connection icon when the software is connected with the test set, the background of this connection status turn green, so it shows the test kit is connected, which also we seen in the first video. Now it is in simulate mode, that's why it's in the background is yellow. And also in the top of the screen we have see inputs. We can also have the advanced mode for this screen, like click a double arrow and advanced, you can able to see the input section, output section, and the select harmonic section. We will go through these screens one by one. The select harmonic section is allow user to set multiple harmonics in the single channel. So let's go through example how to set like voltage and current values to inject the manual testing or performing the manual testing. Say example, I want to inject 1 amps and 63.5 voltage to the relay. So I select here, I click 1 amps, balance it. So all the current channel become 1 amps. I want to inject 63.5 voltage. 63.5, click balance, and you can see all the voltage channels get balanced. The current, in case I want to inject 0 degree and balance, I click balance, then it get balanced. The frequency also we can change. 60.1 example I set, it will balance it. I'm setting back to 60 hertz frequency. So this icons like to control individual channels on off. This is for I1, I2, I3. If you want to turn on all the channels or any one of the channel output, we need to click this turn on all enable channels. This is like we call as a master on. So if I click master on, you can see all the voltage and current will start deliver output. When you connected with the test set, this software have one more feature, the meter mode. If you click the meter mode, if the test set you are connected, it will automatically so what actually it is injecting. You may ask question why we have to see. Sometime when you command to deliver 1 amps and a 63.5 voltage into the relay circuit, but it may be vary, depends on the load impedance, right? In this case the relay CTPT circuits, and also cables we connected. So the voltage or current injection from the test set may vary, but the it's all numerical control. There is called feedback system in the relay test set. It automatically correct the voltage and current. It is try to keep the committed value, in this case 1 amps and 63.5 voltage. So this is the one other feature, user can see how much voltage and current actually test set is delivering. Then I click end meter mode and click end. So this is the screen like simple meter tester. At the same time here, this icon, this space vector diagram, it shows like what is your voltage and current values. As in the vector mode, if I put 30-degree phase angle, you can see the clearly the difference voltage and current channels. It's only vector representation. Okay, example, if I want to do the pickup test, manual pickup test, like current pickup test, my assume like my overcurrent pickup is 2 amps. I want to run the pickup test and find the operating value and add create the report. This is the scenario we want to go through. So what we need for pickup test, we need to inject the current, in this case overcurrent pickup test. So we need to inject the current. So To send the relay feedback or relay operation, so we need to define the trip conduct in the test set. So here in the software configure binary input one, I say this is the binary input one as a, I say name this as a trip in this case, and the input type is a potential free or potential dry type conduct. I selected as a dry type, and it's a NC to NO or NO to NC. So we are looking for the relay to operate, so the NO to NC. I want to configure this conduct as a trip mode, so use as a trip. I want to enable the latch input. I want to turn off the voltage and current the moment I get the feedback. I want to set debounce time, it's a 2 millisecond. It's a standard. So once my binary input is defined, so what I can do, my pickup is 2 amps, right? So I want to do the manual varying, how to set. So I turn on the voltage and current. In this case, if I don't want to voltage, I turn off the voltage. I select only the current channels, click include in the RAM channel. Either I press the mouse scroll bar button or up arrow, down arrow. I can control the current output increment steps. The increment steps can be set from this icon, up, down arrow icon. Click this one. I want to set like a 100 milliamps every step, or I can select auto. You can see the multiple increment option, and which mode you want to select, the amplitude, phase, or frequency, or the which channels you are going to set. So I select like a zero point 0.1 as my increment step, like it is going to increase like in. So it assume like 2 amps or 2.05 relay is operated and injection stopped. I want to get this into the report. What I have to do, add result to the report. You can see like I say like a overcurrent pickup test. Once we define the test name here, we can see here I can define the expected value. Say example, in this case I want to define expected is 2.01 amps. So based on the expected value, automatically min value, max value is calculated, and based on the allowed percentage error, pass fail comes. In this case, 10%. So I said 1%, the test obviously will fail. So if said 5%, based on the percentage error, allowed error, and actual percentage error, it pass. So the test table simply, so like what is your pickup value, actually operated value, we can rename it also here. So I say it is overcurrent pickup value. So my overcurrent pickup actually is 2.05 amps, expected is 2.01. Based on this parameter, allowed percentage error, based on these three values, automatically we define pass or fail. In the bottom of the table, we can also show what is the current we are injected and phase angle frequency in the all the all the channels. So this is the simple overcurrent pickup test manual way of testing. So I go back to the home screen now. So I want to run this one as a timing test. So I know my relay is operated at 2.05. So example, I want to see, it's a assume like it's a time over current normally inverse curve relay. So time over current normally inverse curve relay, if you apply 10 times, it operate in 3 second example. So 10 times of my pickup is like 20 amps. So I selected here 20 amps. I want to inject 20 amps, but it expect to operate in 3 seconds. I want to set pre-fault current values to 0 and balance all the three channel, and maybe pre-fault for 1 second I turn on, and fault for infinity time, or in this case we were going to apply for actual fault operating time by the relay plus a certain time. How we can control, since high current we are injecting, we want to control that, right? So here the test setting, we can define max test time. So I know the relay going to should operate on 3 seconds when 10 times fault is injected. So I said like I may apply 3.5 second, max test time is 3.5. Then pre-fault time is 1 second. The post-fault time, there is no post-fault, it's turn off automatically when the relay is operate or when the timeout happens. So to run the timing test, we need to use the play button, right? So I click play. Then in this case, you can see the pre-fall runs. Then it is going to operate at 3 second, assume. So the relay, I missed the operating time. So I'm going to rerun again. I rerun the test again. Wait for the 3 second operation. So it's operated early, assume in this case. So I want to add this into the report. as a timing test report. Click the report option icon, press add result to report, then it's a timing test. So I say here simply the rename the test as a overcurrent timing test. And we know like pre-fall time is 1 second and max test time operated set is 3.5 second. It doesn't have expected. I'm looking for expected is 3 seconds. So expected is 3 second. Minimum value is zero. Maximum values we can define. So expected is like 3 second. I want to give plus or minus maybe 100 millisecond. I want to give. So here my 2 point or 300 millisecond, 2.7 second minimum. Max is 3.3 seconds. So based on the min and max value is the measure value within this tolerance, test will pass. If it is say example in this case 2.9, I put the tension value, so it will fail. So based on the relay operating values and min max value defined here, the test will pass or fail. This is a pretty straightforward and simple way of testing the relay. So what we see here, two tests we did with the using the same screen. You can see the test result in the predefined test, overcurrent pickup test and overcurrent timing test. It's a pretty easy way to do. We will continue our home screen where features in the next video, because I don't want to kind of load a lot of stuffs. So we'll start with the overcurrent pickup and timing we completed. So I will go for like over voltage, under voltage, or how to use impedance, or how to use the harmonic function testing, or how to use the home screen for running the differential setting. So we will see in the chain of videos. Thank you.